Okay, it says that air is being pumped into a balloon at a rate of 5 cubic centimeters per minute. So just by looking at the units, I can tell that is your change in the rate of the volume. So that is dV dt, so that's 5. And it wants me to find the rate, which the radius, so that's a change in the radius over time, so which is dr dt. So this is what we were trying to find when the diameter, so when d is 20 centimeters. Okay, so we're talking about volume and radius and diameter and all that stuff. We're talking about the volume of the balloon. So we start with an equation that relates the variables. And step 1 is to go ahead and take the derivative. So I'm going to take the derivative with respect to time of both sides. So the derivative of v with respect to t is dv dt. The derivative of the right-hand side is, this is my only variable, r cubed. So I'm going to bring down the 3, which really cancels with the 3 on the bottom here. So I'm left with 4 pi is just a number. Reduce the power by 1. And don't forget, the derivative of r with respect to 2 is dr dt. Now let's plug in my values. This is 5. If you want to put the units in, if that helps you figure out what the final units are, that would be fine. Equals 4 pi. It doesn't give me radius, but it does give me diameter. So if the diameter is 10, I know the radius has to be 10. So this is going to be 10 squared. So really your units here would be centimeters squared, and I need dr dt. So I'm trying to solve for dr dt. So really I've got 100 pi on the right-hand side. So I'm going to take 5 all divided by 400 pi. Notice the centimeter squared will cancel out with the centimeter squared here, so you're left with just a centimeter per minute. So that is dr dt. You can leave your answer like this. If you want to reduce it, it's 1 over 80 pi. If you want to make it into a decimal, you can go ahead and punch that into your calculator. Okay. Next one. It says you've got a ladder that's 20 feet long leaning against the wall of a vertical building. So I've got a house. Here's the wall. Let's assume the ground is horizontal, and there is a ladder that leans against it. And this ladder is 20 feet long. Okay, the length of the ladder is never changing, so this number is a constant, so I do not need a variable for this. The bottom of the ladder is sliding out, so this is the bottom of the ladder here, and that length is going to be changing, so I need to call that a variable. And as the ladder slides out, this vertical distance is also changing, so I'm going to call that a variable y. So let's see what's given and what we're trying to find. The bottom of the ladder slides away from the building horizontally at a rate of 2 feet per second. So this distance, x, is changing. So it is saying dx dt is sliding away horizontally. So notice this distance is getting bigger, so that's going to be a positive 2. It wants to find how fast is the ladder sliding down. So that's the vertical distance, which is dy dt. When the top of the ladder is 12 feet above the ground. So when this is exactly 12 feet up here. So when y is exactly 12. Okay, after we find the given and the find, set up an equation that relates all these variables. So notice you have a right triangle right here that relates x and y and the length of the ladder. So I'm going to start with the Pythagorean theorem. X squared plus y squared equals 20 squared. I need to take the derivative with respect to time because I'm given information about dx dt and dy dt. So the derivative of x squared is 2x dx dt plus 2y dy dt. Derivative of 20 squared, which is just 400, is just a number, is 0. If you want, you can divide out the 2's right away, so you're left with this. At this point, it's up to you. You can plug in the numbers right away or solve for dy dt. I'm going to go ahead and plug in the values. Notice I do not have a number for x yet. It only gives me the y value, but we know this is always 20. I want to know what happens when this is 12. I can figure out this x value at that one moment in time. It is a 3, 4, 5 triangle, or you can use the Pythagorean theorem. So if you do that, this is that length is going to be 16. So there's my x. I know dx dt is 2. My y is 12. dy dt is what I'm looking for. And if I solve this, I end up with dy dt equals, subtract the 32, divide by 12, or if you want to reduce, it's negative 1/3. Units would be feet per second. And it should make sense that that dy dt is negative because it's sliding down as time increases. Okay, next one. An observer stands 700 feet away from a launch pad to observe a rocket launch. So here's my rocket. It's going straight up, and here's the observer over here. And this distance is changing because the rocket is moving. So that's why this distance here is never changing because it doesn't say the observer is moving. So we can call that a constant. And that constant is 700 feet. So he's standing 700 feet away. The rocket blasts off and maintains a velocity of 900 feet per second. So what they're giving you is how fast the rocket is going up. So is the change in y with respect to t, and that's going to be 900. And it says this can be modeled by a right triangle. So let's draw a right triangle here. How fast is the observer to the rocket distance changing? So this is what we're looking for, and that's changing, so we're going to call it another variable z. So find dz dt when the rocket is 2,400 feet from the ground. So that would be y equals 2,400. Again, what's the equation that relates all these variables? Pythagorean theorem. So I've got 700 squared plus y squared equals z squared. Then you take your derivative with respect to t. The derivative of 700 squared is 0. I have 2y dy dt equals 2z dz dt. Again, just to make the numbers simpler, I'm going to divide out the 2 from both sides. And let's plug in what I have. I know y is 2,400. dy dt is 900. I do not have z, but here's your right triangle again. I know this is 700. I want to know what happens when y is exactly 2,400. Here's your Pythagorean triple again. 724, this has to be 2,500. Or you can use your Pythagorean theorem if you need to. So z is 2,500. I'm looking for dz dt. At this point, just use your calculator, do 2,400 times 900, divide out the 2,500, and it becomes exactly 864. And units would be feet per second. And again, this distance is getting bigger, so it should make sense that this is a positive number.